Jy kan gaan.
Dankie. Good morning, grade 12. Oh my goodness, it's afternoon already. Sure, where has this day gone? Wow. Right, guys, welcome to another organic chemistry revision class. We are going to look today at physical properties. Okay, so I am going to, before we even start, give you guys the link for tomorrow's class. Okay, so again, you need to make sure you can find your Q&A, right? And I am going to give you the link for tomorrow's team. All right, so it is in there. And then for those of you who missed it yesterday, the link for the Google, for the drive for you guys, where all the details and stuff is in, that link is also in the chat for you guys. Okay, so that is in terms of housekeeping. Right. Carl, hello. Who else is here? Right. Okay, guys, so I've sent the links so you can find everything. I hope you also had a look at the important documents word that I put into the Google Drive, right? So please make sure that you go and download that and go through it and use it. What I try to do is to condense each section of the physical sciences paper into one document for you so that you have like a bit of a breakdown to study. Okay, so today we are going to look at November 2017, okay, and we are going to do paper 2, which is chemistry, and I'm going to look at question 3. Right, guys, before we start, you need to make sure that you know how they can ask you this question. Okay, there's 4 possible ways. They can ask you by giving you a table of boiling points, or they can give you a table of vapor pressure. They could give you a graph of boiling points, and here they give us a graph of vapor pressure. So it is super, super important that you know your definitions, that you know how to apply them, okay, and then can pull out of the question. Hey, Sean. Hey, Keziah. Pilo. Good job. Guys, before we carry on, okay, we will re-put up, I'll repost all the links towards the end of the lesson. Okay, so don't panic that you might have missed it and now you're not going to get it. I will send it through again at the end. Okay, so let's have a look at this question paper. Cool. So they give us a graph of vapor pressure versus temperature. Okay, so temperature is here at the bottom. Temperature is here at the bottom, and vapor pressure is here on the side. All right. They say that it is 4 straight unbranched alkanes. You see that? Alkanes. Okay. So we don't have to worry about the different types of intermolecular forces. Okay. We don't have to look at hydrogen forces and at dipole-dipole. Okay. If we are working with alkanes, that means that we are only dealing with van der Waals forces, only, okay? They further tell us that it is 4 straight chains. So that means that the branching of the compounds will not play a role. Okay. Then they say from P to S, each compound differs from the previous compound by a CH2 group. Okay, so that means that P is one little bit shorter than Q, and Q is a little bit shorter or smaller than R, and R is a little bit shorter or smaller than S. Now, they give us vapor pressures in millimeter mercury, okay? And they tell us that atmospheric pressure is 760 millimeters mercury, and here they draw that dotted line. Okay, now that dotted line, guys, is beyond super important because let's go have a look, pardon me, let's go have a look at our definitions. Okay, I was nice enough to pull them in here. Obviously, we're not going to work with melting point, but that is a definition you need to know. Boiling point is the temperature at which vapor pressure equals atmospheric pressure. Okay, so there is the important concept that you need to keep in mind and that we now need to apply. Okay, then we also know that the vapor pressure exerted by a vapor, the vapor pressure is the pressure exerted by a vapor at equilibrium. Okay, so we can have vapor pressure at any temperature, all right? And the closer that vapor pressure gets to atmospheric pressure, the closer we get to boiling point. All right, so that is how you would interpret a graph when you are given vapor pressure. You go find the vapor pressure of atmospheric pressure, okay, so 760, and then we can say that P has a boiling point when the vapor pressure is equal to atmospheric pressure of roughly, let's say, 35 degrees Celsius. Okay, so that is how you need to interpret a graph like this. Rightio, Joe. First question. Give a reason why alkanes are said to be saturated. Okay, we had saturation yesterday. You need to know the definition of saturated. Saturated is that you only have single bonds between all your carbons. Kyle, this is 2017, November, paper 2, question 3. Right. So, saturated, we only have single bonds. It's only one mark. So, I think the best way to answer this question, oh my goodness, we're having a day like that today. Okay, so 3.1, it is because, oh goodness. Sorry guys, let me just switch my up a little bit. Let's see if I can write that better. Terrible. So it is, that was too much. Here we go. Alkanes have no multiple bonds between carbons. Okay. Right. So That was 3.1. And then 3.2, they ask for vapor pressure. Okay, guys, can you see how important it is that you know all your definitions? So it is the pressure of a substance when gas and liquid are in equilibrium. In a second, we'll scroll up. In a closed container. There we go. All right, so that wasn't that bad. Again, guys, you need to know your definitions. All right. Here we go. Use the information on the graph and answer the following questions. What is the effect of an increase in temperature on vapor pressure? You only write increase, decrease, or no effect. So let's pick one. Let's go for P. As the temperature increases, the vapor pressure of P increases. So 3.3.1 increases. Nearly enough. Okay. 3.3.2. Which compound has a boiling point of approximately 68 degrees Celsius? Give a reason for your answer. Okay. Now we start with those questions. Selma, yes, your answer is perfect, correct. Alkanes only have single bonds. Perfect. Okay. Right, guys, so now we need to start interpreting this graph quite seriously. They want to know 68, so it's roughly about there. I go find atmospheric pressure, and I see that Q crosses atmospheric pressure when we are at about 68 degrees. Okay, so we are going to say Q. Now we have to give a reason. So we're going to say at 68 degrees Celsius, the vapor pressure equals atmospheric pressure. Okay, is that all right, guys? Man, do the terms saturated and unsaturated refer to hydrocarbons? Okay, so the definition of saturated, okay, is very specific. It is a compound where there are no multiple bonds between carbon atoms, okay? So the second we talk about ketones and aldehydes, I can see, and even carboxylic acid, it becomes a gray area, okay? But when we talk about saturated and unsaturated, we only look at the double bond between carbons, okay? So you could have an unsaturated aldehyde, right? Where you would have a double bond between carbons, but the double bond oxygen does not make aldehyde unsaturated. Okay, so when we look at saturation or unsaturation, right, we only look at bonds between carbon atoms. I hope that answers that question. What question paper are we doing? 2017, November. Paper 2, question 3. Okay. Okay. Which compound has the longest chain length? Fully explain your answer. Tom, tom, tom. I hope you guys know the rhyme for this. Okay. So, we can see that S will have the highest boiling point. Deal? Then the question becomes, what makes this have the highest boiling point? And if we look, we have alkanes and they're all unbranched. So the only thing that influences that boiling point is the length of the group. Okay? And now you need to be super, super solid in your theory. Okay? You need to make sure that your theory is like on point. Okay? So, the longer the chain, the more surface area the two molecules have to interact with each other, which increases the intermolecular forces. Therefore, more energy is needed to overcome the intermolecular forces. Therefore, it has a higher boiling point. Okay, so that is the rhyme you have to use. You have to. Okay, it is what gets you the marks. So the start of each of those type of questions could differ. It depends on what you are investigating. But the rest of the little rhyme stays exactly the same. So I would say that S has the highest boiling point. Okay, S is the longest chain. Let's just double check what the question asked before we answer the question from the wrong side. The question is, which is the longest chain? Okay, so we are going to refer to the boiling point. So why do we say that? I need a pen. Right, why do we say that? It has the highest boiling point. Remember, boiling point you can shorten with BP. Intermolecular forces you can shorten with IMF. All right, guys, so now's the writing part that comes in here. Okay, and again, I know it becomes tedious, okay, but you just need to have this little rhyme. So the longer the chain, the more surface area is available for IMF, which makes the IF stronger. Okay, that's the first part. Now we've got to say, why does IMF influence boiling point? Okay, so you say more energy is needed. An important word here, you don't say break intermolecular forces, you say overcome important word there, IMF. Therefore, it has a higher boiling point. Okay, you guys see the steps I follow, okay? I start by explaining what influence whatever we are investigating has on the IMF. Then, the stronger the IMF, the more energy I have to put in, the higher the boiling point. Okay, Mpilo, what I'll do with this little rhyme, okay, is I will, when I write out the memo for you guys for this one, then I will add that into the memo and I will make like a big block about it. Okay, right. So, the longer the chain, the more surface area is available for IMF, which makes the IMF stronger. This is only applicable when we're working with chain length. So once you've said why the IMF is stronger or weaker, then you go. More energy is needed to overcome the IMF, therefore a higher boiling point. Okay, so that there, this bottom part, more energy overcome IMF and higher boiling point. Those you always write after you've explained why the IMF changes. Okay. Compound P has 5 carbon atoms. Okay. Draw the structural formula of a chain isomer. Oh my goodness, they're not asking us to draw compound P. They are asking us to draw a chain isomer of compound P and the IUPAC name. Okay. Again, guys, IUPAC naming is something you have to be as comfortable as possible with. So, let's approach this question from start to finish. Right. Now, first, we have to know what pentane, because it's got 5 carbons, looks like. So, 4 and 5. Hey guys, my H's are getting like weirder and weirder by the moment. This is compound P, okay? That is not the chain isomer of compound P. That is compound P, okay? Now, they're asking us to draw a chain isomer, okay? Now, this is where your isomers has to be very strong, okay? If they ask you for a chain isomer, then you change the position of a carbon. Okay, so that is what they mean by a chain isomer. So what I'm going to do is I'm going to chop off that little methyl group there and I'm going to plug it in somewhere else. Now careful that you don't plug it in there or there because then it is still pentane, okay? So we only have these 2 carbons to add this methyl group to. Okay, so that means that our longest chain is now going to have 4 carbons. So 1, 2, 3, and 4. And I'm going to take this methyl group and I'm going to add it on one of the middle carbons. Okay. And now I count to 4 and I make sure I add all my hydrogens. So I sometimes wish we just had an H stamp when we're busy with organic molecules. Like, that would make me very happy. Okay, now we have to give the IOPAC name. Now we've already said that the longest chain is going to have 4 carbons in it. I can either count from left to right or from right to left. If I count from right to left, 1, 2, 3, but if I count from left to right, then that methyl group is on carbon number 2, which is the better way of naming it. So 2-methyl butane. There we go. All right, guys. Can you see why I draw the original diagram first? Because they didn't give us any diagram, okay? So for us to be able to know what it looks like is hard. So I strongly recommend that you redraw the chain, okay? And then look, what am I changing? What isomer do they want? Okay. Right. Now for question 3.4.2. How will the vapor pressure of this isomer compare to that of compound P? They didn't even ask any explanation. They just said higher than, lower than, or equal to. So let's look at it. Okay. This is a longer chain. So pentane is a longer chain than butane, and it is less branched. This branching here means that this molecule is rounder than this molecule. The more branched something is, the less surface area I have for IMF to take place. Okay, so that means the more branched. Sean, I see your question. I'll get to it now. The more branched a chain, the smaller the IMF. The smaller the IMF, the lower the boiling point. Okay, ma'am, should we not state the forces and then compare the substance with chain length and boiling point? Yes, Sean, that would not be a bad thing to do. Okay, to state here that all the compounds are alkanes, so only van der Waals forces are necessary. The reason why I didn't is because it's 4 marks, okay? And you're already getting 1 mark here for the S. So that means that you have to get 3 marks out here, and this little line here is already generally 2 marks. Okay, so Sean, you are not wrong in saying that you can state the forces. Okay, you can state here that all the compounds are alkanes, and so only weak van der Waals forces are in question. All right. Teresa, how did I know that S is the longest chain? Let's go back to the diagram, okay? So they very specifically say it's all 4 straight chain unbranched alkanes. Okay, so we know that P, Q, and R and S are all alkanes. Okay. Then we can see that they all have different boiling points. Okay. The question was, which compound has the longest chain? Okay. Because a longer chain has more spaces for IMF than a shorter chain. The longer chain has stronger IMF. Okay. And the stronger the IMF, the higher the boiling point. So I use this graph here to see that S, I mean, at 100 degrees Celsius, it's not anywhere close to vapor pressure. Okay, so I use this graph here to figure out that S has the highest boiling point, and therefore I can say it has the longest chain. Okay, Matthew, the difference between a structural and a chain isomer. All isomers in organic chemistry are structural isomers, all of them. Structural isomer, sorry guys, structural isomers are isomers with the same molecular formula but a different structure. Okay? Chain isomers is a structural isomer because it looks different. Functional isomers is a structural isomer because it all looks different. Okay, you see how it kind of puzzles out. All organic isomers that we deal with in grade 12 are structural isomers, and then we can specifically say what type of structural isomer each of them is. Okay. Chain isomers are in the branches. Yes, sweetie. Good job, guys. 2-methyl butane. Good job. Okay. So, how will the vapor pressure of this isomer compare with compound P? Higher than, lower than, or equal to? Again. Goodness, no, I don't want to do that. If we look at them, P is a long chain, and the one we created is more branched. So the IMF of this branched molecule is smaller than the long one, and because the IMF is smaller, the boiling point will decrease. I think they gave decrease as an option. Let's see what we can write down. Oh, we have to write higher than, lower than, or equal to. So we are going to write lower than. Okay. So the boiling point of this thing we created is lower than. Okay. It is only 1 mark. You don't have to give a reason. Okay. I'm going to write down the reason for you guys just so that you have something to refer back to. Could we have 2,2-dimethylpropane? Carl, that's a good thing. I'm going to go back. Sean, I will explain that. Okay, so let's quickly get to Carl's question because it goes back a little bit. Okay. Then, Sean, I will get to explaining the difference between a chain isomer and a positional isomer. That is a hard one to make, okay? It's not the easiest one to do, okay? So let's have a look. Let's go back to this thing here, okay? If I chopped this methyl group off and I put it there, this would be further branched, okay? I have a little bit of space on this side. So if I chop that methyl group off there and I put it there, I'm going to have 1, 2, 3. This methyl group I've already chopped off, and now I chop off another methyl group. So yes, you could have 2,2-dimethylpropane. Okay. You could have that also as a chain isomer. Okay. Next, the question was the difference between a chain isomer and a positional isomer. Okay. Guys, I'm quickly going to open yesterday's documents for you, because what I did in yesterday's documents is I actually summarized it. Just give Word a second to start. Obviously, I'm running 2,000 programs on this laptop at the same time, so it's been a little bit unhappy. Go. I just need to move it back. Give me a second. There we go. Look, magic. Make all of this smaller so you can see it better, and make it like a ton bigger for you guys. Let's go 200. These away for you guys. Right. Okay. So in yesterday's important questions or important topics, okay, I put a lot of the research or the exam guidelines in there for you, okay? So you need to know the homologous series and the functional group. You need to know the differences between the two, okay? Then there are the different types of formulas that you need to be able to write. And now we get to the isomers. Okay. We have 3 different types of isomers. They are all structural isomers because they all have the same molecular formula but a different structure. But each of these are special. And now I have obviously had to learn how to make up some other little rhyme for me to remember. Okay, so functional isomers I find is the easiest one. Okay, functional isomers got the same molecular formula but different functional groups. There is only 2 sets of functional isomers. Okay, only 2. The one is carboxylic acids and esters, because both those molecules have 2 oxygens in them. Okay, so the one type of functional isomer you can get is esters and carboxylic acids. The other type of functional group that you can get, functional isomers, is aldehydes and ketones. So you take that double bond O and you move it from, it's an aldehyde, then you move it from a primary carbon to a secondary, or we can't do tertiary. So you move that O from a primary carbon onto a secondary carbon. All right. Now, the one I struggle with the most is the idea of chain and positional isomers. Because technically speaking, when I move the carbon, I move its position. Okay. And that's why I learned this C thing here. Okay. So chain isomers are only when I move or change a carbon. When I move, when I change a carbon, I have a chain isomer. When I move anything else, it is a positional isomer. Okay, so that was the way that I had to figure it out for myself. Okay, that chain isomers, I change a carbon. Positional isomers, I can change the position of something else. Okay, right. Like I say, guys, it is a very, very tricky concept. Okay. Selma, yes. So chain isomer is when I move a carbon, where a positional isomer, okay, is I move the OH group, or I move the halogen, or what else can I do as a chain isomer? I think that's about it. Okay. So chain isomers is I move a carbon to create different chains. Teresa asked whether or not the vapor pressure determines the change. it's the other way around. Okay? The number of chains determine the vapor pressure. Depending on how chained my thing is, the intermolecular forces are more or less, okay? And the strength of the intermolecular forces determine the vapor pressure. Luke, yes. So guys, this is on the Google Drive. We've got a couple of minutes left, okay? You will see that we've got the africanteengeeks.co.za. You can register there. If you have already done so and you're telling me, but ma'am, I don't get everything, and go check in your spam boxes. Okay. Then I have created in my own Google Drive for you a folder, okay? And that has got all the resources from the last 4 weeks on, okay? So all the resources from the last 4 weeks. Methyl group moves, it's not a positional isomer. Yes, correct, Matthew. Okay. So I'm just going to ask the moderator to let you guys have, there we go. There's the Google Drive link for you, okay? And then, give me a second. Okay, there is the link for tomorrow's class. Okay, guys. I will put it back on Facebook. I will distribute it again, okay? In that Google Drive, there is also a Word document that says links to classes, week 4. All of these links for all the classes are in there. This document that I've worked off now at the end, okay, is also in there. I referred to this one as important concepts, okay? So it's labeled 12 physical sciences, 2004, and it's got an important concepts at the end. There's one for today as well. There's one for tomorrow as well. There is a workflow or a flow diagram in there for all the reactions, okay? And that has also got a table with all the reaction conditions in it, okay? And all the questions that we're doing this week is in that folder too, okay? Either as a PowerPoint or as a Word document, all right? So that didn't end up being that bad, okay? So last little bit, okay? Tomorrow, I'm going to do an Esther question. It's from 2018, November, okay? My kids, you will recognize it very, very, very seriously, okay? But what I'm also going to do tomorrow is we are going to look at if you have an experiment and they ask you questions in terms of investigative questions, okay? How do you approach them? So we're also going to look at that tomorrow because the Esther question hasn't got a lot of meat on it, okay? But you will always have an investigative question or a practical question in both of your papers. You'll have one in paper 1 and one in paper 2, okay? Oh, Carl, okay, we see. Listen, Carl, the moderator and I are going to try that, the thingy, the linky thing, okay? And then we will get back to you guys. Is there any questions from anyone else? Is everybody okay still? Okay. Then guys, just a reminder, on Friday, okay, I'm going to give you guys the flow diagrams for fertilizers, for the processes, okay? And I'll show you how to do, there's calculations involved, it's ratios, it's like beyond easy, okay? We're going to do that on Friday, and on Thursday we are going to look at reactions in organic chemistry, because I know that reactions in organic chemistry can be a little tricky. All right, you guys, good? Everybody okay? Just waiting for my feed to catch up to you a little bit. Okay, guys, so that is it for today. Wasn't that bad. You guys see, if you just not panic about a question, then it's not that bad. Okay, you have to know your basics. Okay, and then I also promise that in that Google Drive, I just saw it's not there, I will put for you exam guidelines and CAPS document. Okay, guys, have a fantastic day. I hope wherever you are staying warm. It's pretty cold in Cape Town at the moment. Yeah, so I will see you guys again tomorrow. Okay, please make sure you share that link wide and free so we can get our numbers up. Okay, I miss everyone. I really do. And it is so weird to have this delay, because then I see it after you've done it. So it's just weird. Okay, so I'll see you guys tomorrow for Esther Practical. Okay, bye.